We are doing 5.5b today, and it's still dealing with standard form. And it's going to be using what I just showed you with that whole cover-up method stuff, but now you're going to be doing some graphing with it. I don't think you graphed, he didn't show you graphing at all on Friday, did he? With this stuff? I don't think so. Okay. Thursday. What period is this? Thursday. Wednesday, because you guys were flip-flopped. Yes. You didn't do that Wednesday? Wow, you guys have all been gone for math for like a week almost. You have a quiz on the block just over 5.5. So we did 5.5a last week, 5.5b today, 5.5c on Tuesday, and then quiz on the block period. So we're spending a lot of time on this section because it can be a little challenging. Okay, so we're picking up at example 2 in this one. And it is going to ask for a graph. So they're going to say graph x minus 2y equals -2. Okay, so the good news here is you get to review a little bit how you find your intercepts, which is what we just did, but we're going to do it again. And then once we have that, then we're going to plot and graph it. So the graphing part of it is not necessarily the challenging part, I wouldn't say. It's the finding the intercepts that usually causes the problem, and then people can graph it fairly simply from there. So you will need graph paper for today. If you don't have graph paper, where is graph paper up here? I wonder how much. I think there should be enough for everyone to have one. Don't take more than one right now. I need to have my TA make some copies. Okay, so you have this set up. It says graph x minus 2y equals -2. The first thing you have to do is find your intercepts. So we're going to start there. Okay, how do we do that? Cover up, right? Cover up one of each. So if I cover up my, you can't really see this right now because of my airplane, but if, say we cover up the x, okay? If I cover up the x right now, what is my equation? -2y equals -2. Right, so we're going to say -2y equals -2. Okay, that's one equation we have to solve. If I cover up my y, now here's the deal. You're covering up the y and any number attached to it, because if we're making that y a 0, that -2 is going to be -2 times 0, which is just 0, right? So now we're going to cover up this, okay? And now what is my equation? X equals -2. Now the beauty in that is you have your intercept already. There's nothing to solve with that one. So this one's done. X equals -2, so -2 is my x-intercept, okay? We need to find our y-intercept. So what do I do? Right, you're going to solve by dividing by -2 on both sides. So my -2's cancel, and I'm left with y equals, what's -2 divided by -2? 1. Okay, so that's what you did last Wednesday, right? We found our x and our y-intercept. Today, you're going to take it from there. You're going to find the x and y intercepts again, but now you're going to graph it. So we're going to graph. Let me grab a graph here if I can find it again. Remind me later, I'll show you pictures of Kenzie. She's a sweetie. Okay, so if we're going to graph this, think about what these represent. X equals -2 is an x-intercept. Which one is my x-axis? Sorry, my x-axis. The horizontal or the vertical? The horizontal, right? This is my x-axis. This is my y-axis, okay? So where x equals -2, on your x-axis, you move to -2. So that means we're going to the left 2. So that's my x equals -2, okay? Where do I go for y equals 1? Up 1 from 0, 0, right? So y equals 1 is there. So the beauty in this is once you plot those, you only need 2 points to make a line. All you have to do is take a straight edge and draw a line through it, okay? So use I don't care what you use, but something straight. Don't just scribble a line. Take a ruler. If you want to go grip one of my rulers when you're doing this on a test or a quiz, that's fine. But you're going to take a straight edge of some sort. I can't on my iPad, so mine's not going to look as beautiful as yours are. But you're just going to draw a straight line through it. Okay? And that's your graph, and you're done. So you're going to plot your two intercepts and call it good. Okay. Questions on that? Okay. What would the graph look like if I had x equals 3 and y equals -4? Where am I going to go for my x? So up, down, left, right. To the right, right? You're going to go x equals 3 and y equals -4? Down 4. 1, 2, 3, 4. And then you're going to draw that line in. Okay, now the green has nothing to do with the last problem, right? I'm just showing you another example of where you would plot, but that's what it would look like. Any questions on that? Okay, then what a lot of people tend to struggle with on this next one is just deciding, do I go horizontal or do I go vertical with these things? So what we're going to do, here we go. This is like example 3 in the book. Let's say they ask us to graph x equals 3. So we're graphing here. And y equals 3. Okay, so we're going to look at 2 different graphs. Let me pull those up real quick. I wonder if I can copy this right now. Bless you. No, I guess not. Okay, one more. Okay, so 2 different graphs here. Here's what you have to think. Girls. Oh, that's right. This thing's broken. You want to graph where x is always 3. Okay? And we talked about this in first semester. I don't know if you remember this at all. But where x is always 3, you could just plot a bunch of points, right? So like 3, 1. My x value is 3. Or 3, -2. My x value is 3. Okay, so where x is always 3 would be where those points fall. So if I plot 3, 1, and I plot 3, -2, what kind of line am I going to get from those 2 points? Vertical, right? I would get a line through 3 here. So my x value everywhere on that line is 3. Okay, so remember this, when it's x equals, it's always going to be a vertical line. Oops. Okay, x equals is always vertical. Where y is always 3, if you pick some points that have a y value of 3, so 0, 3, 1, 3, or -2, 3, right? My y value there, sorry, it keeps jumping around on me. My y value is always 3. So where y is 3, if I plot those, -2, 3, 0, 3, and 1, 3, what type of line will I get if I connect all those points? Horizontal, okay? So my y equals is always going to be a horizontal line through the number that we're given, okay? So x equals 3 is vertical through 3. Y equals 3 is horizontal through 3. Does that make sense? Okay, so if I said graph x equals -4, and here's my coordinate plane, is it going to be vertical or horizontal? It's going to be vertical. And do I move to the left, to the right, up, or down? Move to the left. So -4 would be over here, a vertical line. Okay, if I had y equals -1, that's going to be a horizontal line, and you're going to move down. So it would look like that. Does that make sense? Okay. So that's graphing that stuff. Last thing we're going to do. Are we done at 11? Yeah? Okay. Got to get back in this schedule. The last thing we're going to do is probably the toughest for this lesson, and it's going to take something from slope-intercept form. Do you remember what slope-intercept form looks like? Right, y equals mx plus b, okay? So we're going to take it from that form, and we're going to move it into standard form, which is ax plus by equals c, okay? So going from slope-intercept to standard, and it can be a little challenging because a lot of times slope-intercept has a fraction in it, but when you move something into standard form, we don't want fractions, okay? We get rid of the fractions. So here's what we're going to do, okay? The question will look something like this. You'll have, this is like example 4 in your book. It'll say, what is y equals negative 3/7 x plus 5 in standard form? And then here's the key part, using integers. What's an integer? Numbers. What kind of numbers? Negatives and positive. They are no decimals, right? So it's the whole numbers, 0, 1, 2, 3, 4, 5, but positive and negative. So the integers are like negative 3, negative 2, negative 1, 0, 1, 2, right? We don't want any decimals. We don't want any fractions, okay? And that's where I think it gets the most tricky for people. So follow me through this, and if you're getting stuck, raise your hand and let me know, and I will slow down, okay? So you have to look at what you're starting with. You're starting with y equals negative 3/7 times x plus 5, okay? We want our x and y to be together on one side and our constant number to be alone on the other side. Can you tell me right now which number is the constant? Which one doesn't have a variable? The 5, okay? So the 5 is the one that's going to be by itself on the other side. But right now we have a fraction, and we don't like fractions in standard form. So what we're going to do is we're going to start by just getting rid of the fraction. So here's where you have to be very algebraic about it, okay? What did you say? You do. You have to multiply, right? Because we want to get that denominator out, so we need to multiply by a numerator that's the same, and then it will cancel it, okay? So what we're going to do is we're going to take this whole side of the equation and multiply by what, do you suppose? Not 5. What will get rid of my 7 on bottom? If you multiply by 7 on top, right? 7 over 7 is 1, so it gets rid of the fraction. So you're going to multiply this whole side by 7, but whatever you do to one side, you have to do to the other, right? So if I multiply this whole side by 7, then I have to multiply this side by 7 also, okay? So let's just rewrite what we have right now. We have 7y on the left, okay? On the right, we're multiplying by 7. So if I take, you multiply by the denominator. Yes. Yep, it'll always be whatever that bottom number is, you want to multiply by it because then it will get rid of it, okay? So you do this, right? 7 times a negative 3 over 7x is going to cancel our 7s, which just leaves us with negative 3x. Okay, but then it's distributive property. If we multiplied 7 by this, now we got to multiply 7 by the next term also. Okay, so we're going to go 7 times 5 is a positive 35. Okay, now the beautiful thing is we have no more fractions, right? How can I then move that into standard form so it looks like this? How can I get my x and y on the same side? Nathan, pay attention. No, because the 7 has a y with it, so you can't combine those. We want this 35. This is our constant. That's our c. Okay, so we want that one by itself. How do I get rid of that negative 3x? Not subtract it. We're going to add it to the other side, right? So if I add 3x here, then I got to add 3x to this side. Can you combine that? No. So what we're going to say is 3x plus 7y equals 35, right? There's nothing left to combine, and now it's in standard form like that. Does that make sense? Okay, let's try another one. Let's say we have y minus 2 equals a negative 1/3 times x plus 6. Okay, so now this is in not slope intercept anymore. This is in, do you remember? Point slope. Okay, but same thing. We don't want fractions. So let's get rid of the fraction first. What would I need to multiply by to get rid of the fraction? If we multiply by 3, it will get rid of the fraction. It'll leave a negative 1 out in front, which just makes more work for you. I would multiply by a negative 3 here, because that'll get rid of the negative as well. Okay? So if I multiply by negative 3 here, the good news is we didn't distribute the 1/3, so we don't need to distribute the negative 3, right? We're just going to get rid of it right here. It's gone. So we just have x plus 6 over here. But then we also have to multiply by negative 3 over here. So if I do that, now this one we have to distribute it. So you have negative 3y, and then negative 3 times negative 2 is a positive 6. Okay, so we're getting there. Now we have no fractions anymore, but we want our x and y together. I would, just so we're not dealing with negatives, I would move the y. So I'd add 3y and add 3y. So now I have this gone. I have 6 equals x plus 3y plus 6. Okay. And now we want all the numbers together. So I'm going to move this 6 out. So this is gone. I have x plus 3y on that side. What's 6 minus 6? 0. Okay, so now standard form would look like that. Okay, and point slope form is the one you'll do less of, I feel like. You'll do more with slope intercept form. So I'm going to do one more in slope intercept form, and then if you want one more after that, we can do another one, but I'll just figure on one and then we'll see how we're feeling. Okay? All right, let's say the problem looks like this. Y equals 2/5 x plus 6. You know what? Try it. And then I'll do it with you. But give it a shot on your own first. So Nathan, or if anyone who's not taking notes, will you get out a piece of scratch paper and try it, even though you don't have notes out? What?
I am so tired.
Well, this will help wake you up because you'll be moving. Get that hand going.
My hand is going.
Well, it's better than if it wasn't moving, right? Good old time change. Everybody loves a time change. Nathan, get it out. Did you know, Mr. Garner told us this morning that on the week of a time change, the spring time change where you lose an hour, car accidents go up by 25% this week.
Oh, yeah, Mr. Garner told us that.
Yeah, he told me that this morning. That's crazy. No good.
We should just keep with the fall time.
Well, you're not driving, so it doesn't matter.
No, but the fall time, we should keep this time.
Not keep this time.
No, I like this time, giving us more summer daylight.
Yeah, I agree. I'd pick this way. I just don't like getting up when it's pitch black out. It's a killer. Okay. How are we doing? Can you tell me what your first step is?
Oh, I multiplied by 6.
Yeah, you do.
You do that. That's what I was
Okay, since we're all telling me what we're doing, we are going to multiply both sides of our equation by what? By 5. Okay, so this whole thing is going to get multiplied by 5, and this is going to get multiplied by 5. Okay, so on the left, you have 5y. What does this become? Why is it doing that?
2x.
This becomes 2x because your 5s are going to cancel. Okay, so 2x plus what? You got to make it 30. You got to take that 5 times the 6 also. So plus 30. Okay, how do I put that into standard form? Take away the 2x. Okay, and here's the thing. That's not the only way you could do it. You could take away the 5y and move the 30 over. So there's really 2 different ways you could see this. But if we take away the 2x, then we get negative 2x plus 5y on the left. This is gone, equals 30. Okay, but some of you might have gotten 2x minus 5y equals negative 30. Okay, both of those are correct. Oftentimes, it seems like the book just picks the one that has the least number of negatives in it, but I will take either one. I'm fine with both. So it just depends what direction you moved your variables, if you moved them both to the left or if you moved them both to the right. Okay? Questions on that? Okay, so if you don't have any graph paper right now, you're going to want to grab a piece of graph paper, but just grab one if you don't have any. And then you have a little bit of time, 9 minutes or so. So see what you can get done.